Welcome to the Math Coach. Today we are going to take a look at one of the more interesting units which involves trigonometric ratios. This how-to video will provide you with examples from trig ratios involving acute and special angles and evaluating any angle between 0 and 360 degrees. Although this unit contains some of the most difficult concepts of the course, with a little work and practice, I guarantee that you will find it enjoyable. I can't wait to get started. So if you open up to 281 in your Nelson textbook, question number 5a, I'm going to take a look at this specific triangle, number 1. And question A says, for each triangle, calculate cosecant theta, secant theta, and cotangent theta of this triangle over here. So when we take a look at this triangle, remember that we can only label the triangle according to the angle theta. The fact that you have 90 degrees in your triangle allows you to use trigonometric ratios from last year. Now, according to this angle theta, this side with the 6 is directly opposite. The 10 is the hypotenuse because it is across from the 90, which leaves this side as adjacent. And adjacent just means beside, not the hypotenuse though. So we can only label the triangle according to the angle. Now, let's take a look at these trig ratios. Cosecant. If we write cosecant in words, just remember that cosecant is the inverse of, or the reciprocal of sine. So sine theta, we know, is 1 over cosecant theta. And likewise for cosecant theta. Cosecant theta is 1 over sine. So it's reciprocal. So we also know that sine of theta is opposite over hypotenuse from the acronym SOHCAHTOA. So if sine is opposite over hypotenuse, and we know cosecant is the reciprocal of sine, that means cosecant has to be hypotenuse over opposite. So just flip the fraction upside down. So if we have the hypotenuse of that triangle and we also have the opposite, then we can find cosecant theta. So cosecant theta, we know, is hypotenuse, which is 10, all over the opposite, which is 6. And we can reduce that, 10 over 6, both top and bottom are divisible by 2. So this is 5 over 3. So cosecant theta is the same as 5 over 3. Likewise, we know that secant is the reciprocal of cos. So secant is 1 over cos, or cos theta is 1 over secant. Now we know that cos theta from SOHCAHTOA is adjacent over hypotenuse. If you don't know these things, you're going to have to look back at your grade 10 notes. But SOHCAHTOA describes all of the trig ratios of a 90-degree triangle. So we know cos is adjacent over hypotenuse. Well, if secant is its reciprocal, then we know that secant is hypotenuse over adjacent. Okay? And we do have the hypotenuse and the adjacent of that triangle. The hypotenuse of that triangle is 10, the adjacent is 8, and we can reduce 10 over 8, both are divisible by 2, so this is 5 over 4. So secant theta is 5 over 4. Likewise, we know that cotangent theta is 1 over 10, so it's the reciprocal of tan theta. And we know that tan theta is from SOHCAHTOA opposite over adjacent. And so if tan is opposite over adjacent, we know cotangent is just its reciprocal, which is adjacent over opposite. Now we have the adjacent and opposite of both of those, of that triangle, and the adjacent, we have both numbers. 8 over opposite is 6. We could reduce that, both top and bottom are divisible by 2, so cotangent theta is 4 over 3. Question 5b asks us to specifically use one of the reciprocal trig ratios to solve this. So I'm going to use this one here. Cosecant theta is 5 over 3. How do I deal with something like this? Well, there's no cosecant button on our calculator. So there's no way that we could actually figure this out. Okay, if I brought cosecant to the other side, just like you would do last year if you were trying to find an angle and you bring cosecant to the other side, it would be the cosecant inverse of 5 over 3. But there is no button on our calculator that has cosecant on it. So when you have a situation like this, we have to change this to something we can use our calculator for. We should understand that cosecant is the reciprocal of sine. So instead of writing cosecant, if I write sine inverse, all I got to do is flip this fraction because I know that sine is the reciprocal of cosecant. So the reciprocal would be 3 over 5. And so if I do this on my calculator properly, some of us can type in the second function sine, and this will show up on our calculator, and then you can open bracket, write the 3 over 5, and then close the bracket, and you will get the answer of 37 degrees when you round to the nearest degree. Otherwise, a calculator like your iPad or iPhone, you would actually have to do this first. 3 divided by 5 first equals, then press second function sine, and you will still get 37 degrees. So how about if I used a different ratio? How about if I used secant theta is 5 over 4? And of course, you should get that theta is 37 degrees also. But actually, I'm going to take this a step further. Some of you may ask, sir, how about if I actually did 5 divided by 4? I actually did this, and I got 1.25, and I ended up with secant theta is 1.25. How would I go about figuring out theta? Again, we know that theta has to be 37 degrees because we just did this problem. And why do I even need to know these reciprocals? And that's a very important question, although you'll start seeing why a little later on. But if I was to do this question the way it stands now, and I was bringing secant to the other side, which would be secant inverse of this 1.25, how would you go do secant inverse of 1.25? Because this thing isn't even a fraction. So how could you take the reciprocal? And to you, I would say, actually, that is a fraction. If I rewrite this as a fraction, this is actually 1.25 over 1, okay? And so if I went to go actually do secant inverse, I can't do that. I don't have a button like that on my calculator, but I do know that cos is the reciprocal of secant, and the reciprocal of this would be 1 over 1.25. So on my calculator, if you have an iPhone like myself that I'm using right here, I would first do 1 divided by 1.25, and I would get 0.8. And then I would take the cos inverse of 0.8, and that would give me, when I round it, 37 degrees. If you have a regular calculator, a calculator that when you type in cos, or second function cos, this word actually pops up on your screen. You could do that, second function cos, open bracket, 1 divided by 1.25, and then close bracket, and you'll get the answer immediately. So the answer would be 37 degrees. That's how you would use reciprocal trig ratios to do this problem. Which leads me to my next example. How about if we were given a situation like this, cotangent theta is equal to this decimal, and it says determine the value of theta to the nearest degree. So once again, we do not have any cotangent buttons on our calculator, but we do know that the cotangent of this thing is 0.5814 all over 1. That is the fraction. So if we wanted to use our calculator, I mean, you could bring cotangent to the other side now, but you could change this right now. We know that tan is the reciprocal of cotangent. So if cotangent is this number here, then we know that tangent is 1 over 0.5814. because it's the reciprocal. And so depending on whether you have a calculator number 1 or a calculator number 2, if you have a calculator like the iPhone and you bring 10 to the other side and you write 10 inverse of this number over here, for me with my iPhone, I'm going to actually have to figure out this number in that bracket first. Some people can press second function 10, get this, open bracket, write this whole number, close bracket, and get the answer immediately. However, for myself, I would actually have to do this division first, and when I do that, I get 1.71998,624. I mean, you don't have to write this number down here. You don't have to actually write this line down here, because since I already have this number in my calculator, all I'm going to do is press second function 10, and I will get 59.8, which is 60 degrees. It's very important that you have your calculator in degrees. Okay, so make sure that your calculator is in degrees and not this RAD, which stands for radians, which you will learn radian measure next year, which is actually true measurement. But for now, we're dealing in degrees. So question number 7 asks us to determine the length of h here. And so if I take a look at this question, the fact that I have 90 degrees in this triangle allows me to use trigonometric ratios, otherwise known as SOHCAHTOA. Now, according to the angle that I have here, 39, I know that this side length here is the hypotenuse, and I know that this side over here is the adjacent side. Okay, and the only thing that relates adjacent hypotenuse is cos. Now, I understand that to do this problem last year, we would write cos theta is equal to adjacent over hypotenuse. Okay, and so let's take a look at what happens here when you go to do this. So we have cos of, let's fill in the blanks. The angle I'm dealing with here is 39 degrees. And I have the adjacent, which is 5. I'll just write 5. And the hypotenuse, which is h. And we're trying to figure out what h is. Now, there's no way of getting rid of this 5 right now. What we'd have to do first is cross multiply the h. So we get h times the cos of 39 degrees is equal to 5. And then in order to leave h alone on this side, we can divide, because this is just multiplication between these two things. So if that's multiplication, if you want to bring cos 39 to the other side, you can divide both sides by the cos 39, or just bring it over to the other side. So divide by cos 39. And so this is what h would be equal to, this fraction. If we wanted to leave it as a true number where it is actually not rounded at all, we would leave it as this fraction. This would be the final answer right here. However, this textbook asks us to round it to the nearest tenth of a meter. So when I do that, I get 6.4 meters. Okay? So that would be the final answer. This is actually not the answer. This is a rounded answer. So the real actual answer is this answer. This is the real answer. Okay? That is not a rounded answer. This would be a rounded answer. So why is that important when dealing with this unit? Well, if we took a look at this, if we wanted to use the real answer, just notice that the real answer is a fraction. And if we needed this answer to do something else, we'd need to put this fraction somewhere else and do some other math with it. Now, if you were to use the reciprocal function over here, the reciprocal ratios in this case, let's try to do this using reciprocal ratios. So if it specifically asks us to use specific reciprocal ratios, we would take a look at what this question was giving us. And the question is giving us the adjacent and hypotenuse. Now, the thing that relates adjacent and hypotenuse is cos. But cos is reciprocal is secant. So another way of doing this problem would be writing secant theta is the hypotenuse over the adjacent. Okay? And so, filling in the blanks here, we have that secant of 39 degrees, which is the angle we're dealing with, is the hypotenuse, which is what we don't know, all over the adjacent, which is 5. The unknown variable is at the top of this fraction. So now in my next line, all I got to do is cross multiply the 5, and I will get 5 times the secant of 39. Please do not do 5 times 39 because the 5 is a side length and the 39 is an angle. So this is the proper way of writing that right here. So h is equal to 5 secant 39. That's the final answer. That's not a rounded answer. It is much nicer to have this as a final answer where it's not a fraction. That's much nicer than this. However, since this question specifically asks us to find the answer to the nearest tenth, if you did have this scenario right here and you were asked to change this line and actually figure out what h is, that's not an issue because we know that 5 is fine, but what does secant 39 mean? It means 1 over the cos of 39. That's what secant of 39 means, right? We know that secant theta is the same as 1 over cos theta. So secant 39 is the same as putting it on the bottom of that fraction, right, as cos 39. So we could still find h, and notice that this is the exact same line as this here. And when you do 5 divided by cos 39, you get 6.4. Question 9 asks us to explain why cosecant theta has to be greater than and equal to 1. However, I'm just going to look at greater than 1, and why cos has to be less than 1. Okay, so I don't want to talk about greater than and equal to just yet. We'll do that a little later. But why does this have to be greater than 1? Well, we should know what cosecant theta is equal to, and we should also know what cos theta is equal to. We know that cos theta from SOHCAHTOA is adjacent over hypotenuse. Okay, and we know that cosecant theta is its reciprocal, which is hypotenuse over adjacent. So, why does cosecant theta have to be bigger than 1? Well, cosecant theta has to be bigger than 1 because the hypotenuse, this number at the top, has to be a bigger number than this number at the bottom. For instance, this could technically be 5 as the hypotenuse, and the bottom number could be something like 3 as the adjacent. That's okay because the hypotenuse, remember, has to be the biggest side. Okay? The hypotenuse has to be the biggest side in the triangle. So if you have the top number as the biggest number of that fraction, right? Doesn't matter what you pick the top number, that means that the adjacent has to be smaller. Okay? So the adjacent has to be smaller than the hypotenuse. So if the adjacent is smaller than the hypotenuse, such as something like this, or, I mean, you don't have to have the bottom number as 3. You could have the bottom number as anything less than 5. So you could have chose the bottom number to be 2. And understand that 5 divided by 2 is 2.5. If you do this as many times as you want, hypotenuse bigger than the adjacent, whenever you do a bigger number divided by a smaller number, you're always going to get that fraction is bigger than 1. Similarly, over here, we also know that the adjacent side for cos has to be smaller than hypotenuse. This has to be larger. Okay, the hypotenuse has to be the biggest side. So some case that you can come up with for cos, I mean, the hypotenuse has to be the largest side. So it doesn't matter what this hypotenuse is. It could be 4, it could be 5, whatever you want. However, the adjacent has to be a smaller number, like 3. Okay, so notice that if you had this scenario, this would be just 0.75. So no matter what, this is always going to be smaller than 1. And likewise, the question could have asked you a little bit different. Why, okay, so why does cosecant theta equals, let's say, something like 0.5 not valid? Okay, so why is this impossible to do? Why is this not valid? Okay, why is cosecant of 0.5 not valid? The reason why is because cosecant theta, as a fraction, we know 0.5 is just 1/2. And we also know the definition of cosecant theta. Cosecant theta is hypotenuse over adjacent. Well, this is impossible. Why is this impossible? Because we know that if the hypotenuse, the top number is 1, the adjacent cannot be 2. That's impossible for a triangle. The hypotenuse always has to be the biggest number. So it is impossible to find theta in this formula, cosecant theta equals 1/2.
Ski jumping is also a sport where angles are important to consider. Skiers go down an in-run, jump, and attempt to land as far as possible down the hill below. Early ski jumpers would keep their skis parallel, but in the 1980s and 1990s, skiers adopted the V-shaped formation. This new acute angle became the preferred method because it provides 30% more lift in the air. And better airlift means a better shot at bringing home the gold.
On page 299, question 1, it asks us to sketch sine of 315, figure out the acute angle, and what the sine of the ratio is. However, we're going to actually figure out what the sine of 315 is. We know that sine of any angle is opposite over hypotenuse, but according to our 5.4 lesson, so if you look at the 5.4 lesson, you can figure out the terminal arm stuff in that lesson. And during that lesson, it explains that the opposite side is called y and the hypotenuse is r. So we have to figure out the y and the r value for the drawing of sine of 315. So if I go to draw sine of 315, what would that look like? So I have a axis here, and remember the terminal arm always starts at an angle of 0. This would be the terminal arm, and this is 0 degrees. And in order to open up to 315, remember this is 90 degrees, this is 180, this would be 270, and all the way around would be 360 degrees. So if I open up to 315, it's going to be somewhere in this quadrant here. Remember, this terminal arm goes around and around and around in a circle, and to open up to 315, it means it's bigger than 270 but less than 360. So this is 315 degrees there. Now if we draw a line that goes up to the x-axis like this, there actually is a triangle inside here, a 90-degree triangle. And we could understand that this angle inside here has to be 45, because remember, a full circle has to be 360. So we have this 315 all the way up until here, plus another 45, that gives us 360. So that's got to be 45. And so does this. This also has to be 45, because this is all the angles add up to 180. So this is a 45, 45, 90-degree triangle. Now we've seen this triangle before. It's just a special triangle. The special triangle that we first showed you is an isosceles triangle, isosceles 90-degree triangle, where both side lengths we have as 1 centimeter, let's say, or 1 mile or 1 kilometer. So these are both 45 and 45, and we use the trig identities or even the Pythagorean theorem to figure out that this is square root of 2. So we can actually draw this in that picture over there. So that's what I'm going to do. I'm going to label the sides. The side length from here to here, across from the 45, this is going to be 1. And more importantly, it's not just going to be 1. You got to realize that according to the axis, the x-axis, this is actually a negative 1, because to go from here downward, that is the height of that triangle is negative 1. And this over here, the x value from here to here, that would be positive 1, because that's to the right. This is the origin. This is to the right by 1. So this point right here on the terminal arm would be 1 for x and negative 1 for y. Okay, so this is your x and your y. And of course, we have the hypotenuse of that triangle being root 2. Okay, so this is your triangle. We know that your y value is right here. This is your y value. This is your x value over here. Your x is 1. And this is your r value right here. Your r value is root 2. So in reality, if according to this picture, if we wanted to find the sine of 315 degrees, that should be no problem. We could do this without any calculator, because we do know the value of y and we do know the value of r. The value of y happens to be negative 1, and the value of r happens to be root 2. So this is the final answer. Sine of 315 is negative 1 over root 2. However, we would not keep the final answer as negative 1 over root 2. So I'll explain this in a second after I erase all this. Our final answer should never have a square root, a radical, on the bottom. The denominator can never have a radical. So the way that we're going to get rid of this square root 2 on the bottom is something called rationalizing the denominator. So you definitely have to know how to do this. So how do we rationalize the denominator? How do we get rid of that square root on the bottom? Remember, whatever you do to the bottom of a fraction, do to the top of the fraction, you don't change the fraction. So what we're actually going to do is we're going to multiply both top and bottom by square root 2. So how will that help us? Well, let's take a look. If we do this, multiply the bottom by itself, we should know that square root of 2 times square root of 2 is just 2. Or square root of 2 times the square root of 2 is the square root of 4. Okay, and on the top, negative 1 times root 2 is negative root 2. So we end up with sine of 315 degrees is equal to negative 2 all over root of 4 is just 2. So that is what's called rationalizing the denominator. You can have a radical on the top, so on the numerator, you just can't have it. It's not proper form to have it on the bottom. So the back of the textbook would have this as the answer, the rationalized version. How do you double check to see if this is correct? Well, if I do the sine of 315 on my calculator, I get the number negative 0.707106, and this number goes on for quite a while, but I'll write that many numbers. If I do negative root 2, so the negative of root 2 divided by 2, actually I get the exact same number. So I know that sine of 315 is equal to negative 0.707, and I did this without a calculator. So this is what our objective is to do these things without a calculator. The only way you could do that is if somehow, some way, special triangles are involved. Question 1D asks us to find the tan of 225. It actually doesn't ask us to find it. We're going to find it anyways, just as practice. But it asks you to find the related acute angle B and the sine of tan 225. So this is what we would do. The first thing we're going to do is we're going to draw tan of 225. So remember that our terminal arm always starts at angle 0, right? And to open up to 225, remember this is 90 degrees, this is 180 degrees here, this is 270 there, and up to this point, one full rotation would be 360 degrees. Now we know that 225 is somewhere in here. So that means in order for this to open up 225, this would be 225. It would be bigger than 180 but less than 270. So all the way up to there would be 225. We know, obviously, that this terminal arm rotates around and around and around in a circle. Now, we also know little tricks, right? We do know the Castrol, and we understand that if you end up in this quadrant here, 10 is positive. So really the question is just asking, what's the sign of this? Well, the sign of this is definitely positive. If you took the 10 of 225 on your calculator, it would be a positive number. But this is the explanation for why it's a positive number. Also, what's the related acute angle? Well, if you draw the triangle that this forms inside here, the 90-degree triangle is always drawn up into the x-axis. This little bit right here, how much is that? Well, that little bit right there is actually 45 degrees. How do I know this? How do I know that's 45 degrees? Because I know that from here all the way to here is 225. So I know that's 225, okay? But I know halfway, just up into here, is 180. So if you take a look at this much, 180, plus this much here, plus a 45, that would give me the 225. So we know that the related acute angle, the little angle inside there, is 45. So that's what it means by what is the related acute angle. The related acute angle B would just be the 45 degrees that is left inside the triangle right there. Okay? But if we were trying to find the actual tan of 225, how would that look like? And basically, drawing this over again, we know that tan of 225, remember, tan of any angle is opposite over adjacent. However, we don't call it opposite and adjacent anymore on the terminal arm. So please look at the 5.4 video of mine with the explanations on the terminal arms and all the quadrants. We know that opposite is actually y, and we know that the adjacent is x. So if we know the y value and the x value of the triangle formed when we draw tan of 225, then we could figure out what tan of 225 is. So remember, 225 means that you end up in this quadrant here. From here all the way to here, that was 225 degrees. Okay? And again, if we draw a line going straight up to the x-axis where that forms 90 degrees, we can tell, we know that this much is 180, right? We know this much is 180 up to this point. So that means that this little bit here, and I'll draw that in green, this little bit here has to be 45. Okay, so this is a special triangle inside of quadrant. Remember, this is quadrant number 1, quadrant number 2, and quadrant number 3. So this is a special triangle in quadrant number 3. How do I know that's a special triangle? I've seen this triangle before. I can construct this triangle anytime. I never memorize these triangles. That's a special triangle where you have a 90-degree isosceles triangle where these are both 45 degrees, obviously, if it's isosceles, and we've called both of these sides 1. And if those sides are both called 1 and use the Pythagorean theorem, you'll figure out that that's root 2 if you use the Pythagorean theorem properly. So labeling this triangle, that's easy. The hypotenuse is very easy. Hypotenuse is always a positive number, so I'll label that first. That is a root 2. Now, across from one of the 45s is a 1. So I'll draw this as the 1. Remember, that is not 1. That's actually negative 1 because from here down, your y value is actually negative 1 because you're going down. So this is your y value, negative 1. And your x value from here all the way to there, okay, your x value is also negative 1. Okay, so your x is also a negative 1 because from the origin to the left. See this point right here, that point right there, which I'll actually draw in yellow right here, that point is going to be my x value is -1 and so is my y value, -1. That's the point -1, -1. This point right here in yellow. Regardless, if we wanted to find the tan of 225, that should be pretty simple now, because the tan of 225, remember, we just have to know what the y is and what the x is. We do know those values because this ends up being a special triangle. If you don't end up with a special triangle in there, if the related angle in there is something like 70, well, we don't know how to find the tan of 70 or any of that stuff, because those are not special triangles. But according to this drawing, the y value is -1 and the x value is also -1. And -1 divided by -1 is +1. So the tan of 225 is +1. And you can try that on your calculator. If you take out your calculator and take the tan of 225, you actually get +1 as your answer. So question 2b gives us a point, and the point is -8, 3. So your x is -8 and your y is 3. It says each point lies on a terminal arm, angle theta in standard position. So if we were to draw this picture so it opens up to the point -8, 3. So if we were to draw this terminal arm so it opens up to the point -8, 3, let's take a look at what that would look like. So this is the terminal arm and it always starts at 0. Now the point -8, 3, obviously -8 for x is going to be somewhere on the left, okay, by 8 and up by 3, okay. I'm not going to draw exactly 8, 3, but somewhere in this quadrant, okay. I don't know where, but somewhere in there, okay. This point is going to be -8 for x and 3 for y. That means it opened up by this much in order to get to that quadrant. That is angle theta. That is the first question. Draw a sketch of angle theta. There's the sketch of angle theta. It has opened up into quadrant 2 for the terminal arm to touch this point -8, 3. It asks us to determine the value of r to the nearest tenth. So if we draw a line straight down to the x-axis like this, where this forms 90 degrees, we can actually label this triangle. See, I do know the height of this triangle. The height of this triangle is right here, is your y value, okay? Your y of that triangle, your height of that triangle is +3. And I do know my x value. My x value is right here, okay? And my x value is right there, -8. X is -8. So I have my y and my x values here. I just have to figure out what r is. And that shouldn't be a big issue. We could figure out r because we know from the Pythagorean theorem or from the equation of a circle, r squared is equal to x squared plus y squared. And so if I plug in my appropriate values here, I know that x is -8. So I have -8 squared plus y is 3 squared. I end up with r squared is equal to 64 plus 9. And so r squared is equal to 73. And so r is equal to the square root of 73. Okay? Because I take the square root of both sides here. Now, I can't break down the square root of 73. So it'll just stay as the square root of 73, but we'll talk more about this later, breaking down square roots. So r, the radius, is the square root of this number 73. Then it says determine the primary trig ratios. It's very important they said primary. Primary means sine, cos, and tan. If they wanted the other ones, they're the reciprocal ones, cosecant, secant, and cotangent. They could ask you those as well. However, it says the primary trig ratios. So no problem. If I go to do the primary trig ratios, we know that sine theta, okay, is always equal to opposite over hypotenuse, or y over r. And in this case, we know that the y value is 3, and we know that the r value is root 73. So that is sine theta. Now, you can't leave your final answer with a square root on the bottom. So how do you do this? How do you get rid of this? You have to what's called rationalize the denominator. How do you rationalize it? You multiply both top and bottom by that square root of 73, like I showed you in the previous question. So we end up with sine of theta is equal to, on the top, 3 times root 73 is 3 root 73. And on the bottom, root 73 times root 73 is just 73. Okay, so that's actually the correct final answer when you rationalize the denominator. Then let's go on to cos. And we know that cos of theta, we know cos is adjacent over hypotenuse, or we will call it x over r, the appropriate language. And so x in this case is -8 all over r, which is root 73. And so that's the answer for cos. However, we have to rationalize the denominator. So we cannot have the final answer with a square root on the bottom. So no square roots on the bottom of a fraction. So we have to multiply both top and bottom by square root of 73. So we end up with cos theta is equal to -8 times root 73 is -8 root 73. Okay, and all over root 73 times root 73 is 73. Okay, so cos theta is equal to that, all that stuff. Then when we move on to tan, we know that tan theta is y over x, opposite over adjacent, and we could understand that, of course, tan theta, if we look at what this is giving us in the picture, we know that the y value is 3 and the x value is -8. So that's what tan theta is equal to. So tan theta, I'm going to write the negative out front because it's not proper format to have the negative on the bottom. So -3 over 8. So this is what tan theta is equal to. Now notice, sine of the angle that you're dealing with. Remember, the angle that you're dealing with is this opening right here, this much. That's how much it opens by. We should understand that that value has to be bigger than 90. So we know that this up to here is 90, and we know that this up to here is 180. Of course, the angle that we're dealing with is this much here. This angle that we're looking for is between 90 and 180. It's an obtuse angle. We know theta has to be obtuse. Okay, so it has to be bigger than 90 and less than 180. We know this, okay? So our final answer has to be an answer in between those two numbers. If it's not, we're going to have to appropriately fix it somehow. Now, also notice that this point is in quadrant 2, like we had mentioned before. It's in quadrant 2. And in quadrant 2, according to the Castrol, we know that the Castrol states that in quadrant number 2, the only thing that is positive is your sine, which is correct. If you look at your sine theta, this is a positive number divided by a positive number, which is positive. If you look at your cos is negative because it's negative divided by a positive here, and your tan also is a negative number. So that all adds up, okay? In quadrant 2, the only thing that is positive is your sine ratio. Now, question number 4 asks us to calculate the value of theta to the nearest degree. So does it matter which one of these you choose to calculate theta? And the answer is no. What I would pick is the easiest thing to use. Now, the answer may not give you the answer right away. However, you want to pick the easiest of all three. And the easiest of all three, in my opinion, I mean, maybe it's not in yours, but in my opinion, I see this tan theta as the easiest. It's just 3 over 8. It's not any of this stuff, all this square root 73s and all that sort of stuff. I don't want to deal with that sort of stuff in my calculator, so I won't. I'm going to actually use tan theta equals -3 over 8 to figure out what theta is. Just remember that the answer must be an answer between 90 and 180. So if I go about my business from last year and I do this to figure out what theta is equal to, and I bring tan to the other side, this ends up being tan inverse of negative 3 over 8. And when I actually plug this into my calculator to figure this out, and rounding it, let's say, to the nearest degree like the textbook says, I end up with negative 20.55, so let's say negative 21 degrees. Now, clearly, this is not the right answer. This is clearly not the correct answer. Obviously, the opening here, this opening has to be an opening that is bigger than 90 but less than 180. So what is this telling us? All that this is telling us is that this related angle that is in here is your 21 degrees. That's what it's telling us. It's saying from the x-axis here, go back by 21 degrees. So in order to fix this answer, all I'm going to do is, I know that up to here is 180, so I'm going to take 180 and I'm going to go backwards by 21. So I'm going to subtract 21, and that's where I will get my answer of 159 degrees. So 159 degrees is actually my answer. How do I know I'm correct? I mean, I could plug this back in right here and do tan of 159 degrees, and it should give me negative 3 over 8, or something very close, because we obviously rounded this number. So how is this connected to sine and all that, right? If you did use sine, so if you did use sine on this one, and you took, sine inverse of whatever that was, I don't remember the number here, but whatever that was, you would actually get that theta is 21. And once again, that is not the correct answer. You have to fix that answer. How do you fix that answer? All that's telling you is that the acute angle right here, that little angle right in here, that is your 21 degrees in the picture. You got to look at the 180 and go backwards by 21 there. So that's what that is telling you. It doesn't tell you the answer directly, it's giving you the answer indirectly. However, if you chose to use cos in this case, and cos theta was equal to some other stuff, if you did cos in this case and you did the cos inverse, that one actually in this particular question, not all the time, but in this particular question, would actually give you the answer immediately. But it doesn't matter which one of these you use. They all give you the answer, sometimes just indirectly. You got to be able to fix the answer according to your actual picture, and that should be no problem, because usually they're going to give you the acute related angle somehow, and you have to fix your number and according to what kind of angle you're looking for. And we knew this angle was between 90 and 180. So let's try 2C, which is the exact same question of drawing a terminal arm, and it asks us to draw a terminal arm up into this point. X is negative 5 and Y is negative 8. So if I were to draw a terminal arm, this is how you would go about doing it. You got your Cartesian plane. You also have your terminal arm starting at 0 degrees. Now, in order to open up to the point negative 5, negative 8, just understand where that is. Negative 5, negative 8 is somewhere in this quadrant. I'm not going to draw exactly with actual points. You could if you wish, but negative 5, negative 8 has to be in this quadrant here. Negative, you got to go to the left by 5 and you got to go down by 8. I didn't draw exactly what it is, but that's how you would draw this. And so in order to even get this drawing, the terminal arm had to open up all the way over here. That is theta. We know that up to this point is 180 degrees, and we know up into here is 270 degrees. We also know that this is quadrant number 3. So we are actually looking for this theta that we're looking for has to be bigger than 180, but less than 270. We have to remember that, so that if we have to fix our final answer, we have to remember that the number we're looking for is in that, between that gap. So if we draw a line always to the x-axis, so it touches the x-axis where this is a 90-degree triangle, this is your 90-degree triangle right there. And we know that since this point is negative 5, 3, we know the x value, right? The x value is negative 5, so I'll label that with red. And so your x value is -5 on that triangle. And we also know that your y value, which I'll label in blue, actually I'll label in green, your y value is -8. So my y value of this triangle is -8, okay? So we know those two. Now we have to also try to find my r value. R value is not that big of a deal. I mean, we could find the r value because we know that r squared is equal to x squared plus y squared. And so r squared is equal to x, which is -5 all squared, plus y, which is -8 all squared. And so we're going to get that r squared is equal to 25 plus 64. And so r squared is going to be equal to 89. And so taking the square root of both sides, I'm going to get that r is equal to the square root of 89. You actually cannot reduce the square root of 89. We'll talk more about that later. But then it asks me to come up with the trig ratios for these. So the trig ratios shouldn't be that big of an issue. If I am going to find sine theta, we know that sine is always y over r. And so we have the y value, which is -8, and we have the r value, which is √89. Once again, you're going to have to rationalize this denominator. How do you rationalize the denominator? We'll have to multiply both top and bottom by the square root of 89, because we do not want to have radicals on the bottom of our fractions. So no radicals on the bottom. So you get -8 times √89, which is -8 √89. And on the bottom, √89 times √89 is 89. This looks like a complete mess. Probably not something I'm going to use to figure out theta in the future. However, this would be the correct answer for sine. Now, if we take a look at cosine, we have a similar situation because we have cos theta, and we know cos is x over r. And so cos of theta is going to be x, which is -5 over r, which is √89. Now I'm going to allow you to write this correctly because this is not correct. You have to rationalize the denominator, so do what I did there and multiply both top and bottom by √89. And you should get -5 √89 over 89. So that would be your cos theta. And then of course your tan theta. And I know that tan theta is going to be always y over x. And so tan theta is going to be y, which is -8 over x, which is -5. Or tan theta is equal to negative divided by a negative is a positive, so 8 over 5. Okay, so this is tan theta. Now notice on tan, we didn't calculate x or y. We had to calculate r. So I'm going to avoid using sine and cos to find theta, although I could. There could have been some mistakes that I've made, rationalize the denominator and so forth, so I'm not even going to bother. But I do know, according to the Castrol, that if you take a look at the Castrol, in quadrant 3, which is the quadrant we're dealing with, the only thing that is positive in quadrant 3 is tan. If you take a look at your sine ratio, it's a negative, and so is cos. But tan is actually positive. So that actually makes some sense. Now, if we want to go figure out what theta is actually equal to, that's not an issue. We're going to bring tan to the other side, and we're going to do the tan inverse. Now, understand that this is probably not going to give you the correct answer right away. Remember, the answer we're looking for is in between 180 and 270. And if I continue this over here, I'm going to get that theta is equal to, and it wants it rounded to the nearest degree, I get 58 degrees when I round it to the nearest degree. Clearly, this is not the correct answer. This is not an answer that is in between 180 and 270, clearly. So what is that telling us? All that's telling us is that this little related angle in here is your 58 degrees, right in here. So this little bit right here is your 58 degrees. Okay, so how do I fix this answer? This shouldn't be that big of a deal. We know that from here up to here, half of a circle is 180. And we also have to add this 58. So we have 180, so I'll draw this in red. We have 180 and this 58 to equal this theta. Okay, so the way we're going to fix this is theta is going to be the 180 plus that related acute angle of 58 degrees. And so the answer is 238 degrees. Okay, how do I know I've done this right? Well, if I plug this in right there, and I actually do tan of 238 degrees, it better be equal to 8 over 5, which is 1.6. Now, it's not going to be exact because obviously this is a rounded answer, because when we did this, that is actually not exactly 58, it's 57.9 or something like that. So this is going to be a little off, but nonetheless, tan of 238 is very close to this positive 8 over 5. So question 3 wants us to use the method that was in example 3 of the textbook to determine the primary trig ratios for each given angle. So how about if the angles end up being one of the angles that are exactly on the axis? What I mean by that, if you start here, your terminal arm starts at angle 0, okay? If you go all the way around, it'll come back to 360 degrees. I mean, if you hit this axis here, this is 90 degrees. This one is 180 degrees. And this one here is 270 degrees. So how about if your terminal arm opens up to one of those axes? Now, it's asking me to figure out the sine, cos, and tan of 270 degrees. So if I did open, if this is my theta in standard position, there's my theta in standard position, and I open up to 270 degrees. To open up to 270, I got to go up to there. That would be 270 degrees. Okay, so this is 270 degrees. Now, if that's 270 degrees, I got to think of what exactly is the point on the terminal arm where this lands. So what is this point right here? Let's make up a point, okay? And that's what your textbook does. What point could this possibly be? Well, no matter what, this point is on the y-axis, right? This is the y-axis. It's on the y-axis. It's 0 for x and anything downward for y. So your y value would be something like, let's say, -1 or -5 or -10 or whatever it is. Your x is 0 and your y is -1. This point right here, which I'll highlight in green, that point right there, is the point 0, -1 or 0, -10 or 0, anything. I've labeled that as 0, -1. Now, if this is the case, how do you calculate your r value? Your r value is always calculated the exact same way. R squared is always equal to x squared plus y squared. And so r squared is going to be my x, which is 0, all squared, plus my y, which is -1 all squared. So r squared is going to be equal to 0 plus 1. So r squared is going to be equal to 1. Take the square root of both sides. R is also equal to 1, which makes sense because this is the middle to the outside of the circle. The radius is also 1. Now, we have x, y, and r. We have that x is 0, we have that y is -1, and we have that r is 1. If we have all these values, there should be no issue for figuring out sine, cos, and tan. So let's figure out sine first. If we figure out sine, we know that sine of 270, okay, because that's what we're figuring out. Remember, sine is y over r. So sine of 270 is y, which is -1, over r, which is 1. So when you do sine of 270 on your calculator, you're going to get the answer of -1 divided by 1, which is -1. And you could try it. Try sine of 270. But you would never, if it asks you sine of 270, you're not going to just type that in your calculator. This is what it wants you to show using the terminal arm. And then if we move on to cos, and we're going to do cos of 270, if you look at the cos of 270 degrees, we know that the cos is always x divided by r. And in this case, we know cos of 270 is going to be your x value, which is 0, divided by your r value, which is 1, and 0 divided by any number, it doesn't matter what it is, 0 divided by anything is just 0. It's not undefined. We're not dividing by 0. It's 0 on the top. So 0 divided by 1, it's 0. So if you did the cos of 270 on your calculator, it would be 0. And let's move on to tan. So if we were to do the tan of 270, we know that tan is always y over x. And so we know that tan of 270 is going to be y, which is -1, divided by x, which is 0. So tan of 270, -1 divided by 0, is undefined. Okay, so you can't do the tan of 270. You can't divide by 0. So this is undefined. If you actually did tan of 270 on your calculator, it would say undefined or error. And I would try to do this with the angles of 180 and 360 with these guidelines. Question 4 is a nice tricky one. It says use the related acute angle to state an equivalent expression. So cos of 300 is the exact same as cos of something. So we have to figure out what else this is equal to. Let's figure this out, okay, using the terminal arm and drawing cos of 300. So cos of 300, we know that if you were going to get into the 300, it has to be after 270, but less than 360. So cos of 300 is going to be in here, in this quadrant here, up into this, like this. And this is 300. Okay? And if we draw a line straight to the x-axis, like this, where this is 90 degrees, we know that this related acute angle is 60 degrees. So that triangle in there, you end up with a triangle that is a 60-degree triangle in there. Now, according to the Castrol, this right here, cos, is positive in this quadrant. We have to figure out where else is cos positive. The only other place that cos is positive is in quadrant number 1. So there's another angle in quadrant number 1 that is exactly the same as cos of 300. So if I draw on the side the exact same picture, except I have this triangle right here in quadrant number 1, I would end up with a picture that looks like this, okay, in quadrant number 1. And if I draw a line straight down to the x-axis, there's my 90-degree triangle. Again, if this is a mere replica in quadrant number 1, that means that this is 60. Okay, so cos of 300 is the exact same as cos of 60. You can try that on your calculator. If you did cos of 300, it would be exactly the same as cos of 60. This may be a little confusing, so we'll do another one for you. So the next one asks us to do tan of 110. So tan of 110 degrees. That has to be equivalent to the tan of some other number. If we draw a Cartesian plane, I'm going to leave room this time to draw another Cartesian plane, but if we draw a Cartesian plane and we're going to do the tan of 110. So if I was to draw 110, if this is the terminal arm in standard position, this is 90 degrees and this is 180 degrees. So I know in order to be 110, it has to end up somewhere like this, okay? This is your 110. It's just past 90. So this is 110 degrees, okay? Leaving us with this. Now, if I draw the associated triangle in this quadrant, it would look like this. Now, if that's 110 here, right, we know that this opening that it opened to from here all the way to here, if this is 110, then we know this associated acute angle has to be 70 in here. How do I know that's 70? Because 110 plus another 70, that has to give me the 180. That is up into the straight line right here, 180 degrees. So that's what I have here. So if I look at the cast rule, so this is very important, the cast rule states that in this quadrant, only sine is positive. Remember, we're looking at the tan of 110. Tan is negative in this quadrant. There's only one other place that tan is negative. The only other place that tan is also a negative would be in this quadrant here, in quadrant number 4. So tan is negative in quadrant 2, but it's also negative in quadrant number 4. So I'm going to draw the exact same picture that I see over here, the exact same picture, except I'm going to make sure I draw this picture in quadrant number 4, because I know that tan is also negative in quadrant number 4. Okay, so drawing that picture, no problem. I'm going to end up with a triangle that's 70 degrees in there. So here is my terminal arm, and I'm going to draw this where I end up with that exact same triangle, except in quadrant number 4. And we know that this exact same triangle, this has to be 70 degrees. Okay, then I can find this theta right here. So I can find out how much this angle is. This angle shouldn't be an issue because I know up until this point is 360. So it starts at 0, ends at 360. So how do I find that big opening? That big opening is just going to be 360 minus this little 70. That's right there. And so I end up with 290. So tan of 110 is the exact same as tan of 290. And you could try that on your calculator. I would just type in both of those. They should be the exact same number. Let's do another one, exactly the same type of question, except this time we'll look at number 4D. And this time we're going to look at sine of 350. Now sine of 350 has to be equal to the sine of some other number. We have to figure out the exact same other number. So let's draw sine of 350 and let's talk about which quadrant it is in and so forth. So I'm going to do the exact same thing. I'll draw the terminal arm here and I open up for 350. Remember, this is 0 and it's also 360 if it goes all the way around. Now 350 looks like this. It starts here and goes all the way around almost to 360. Okay? Goes up into there. So that is your 300. That big thing right here, this big opening is 350 degrees. And if I draw a line straight to the x-axis, there's my 90-degree triangle in quadrant number 4. Okay? And that leaves me with this acute related angle for 10, because clearly 350 all the way to here plus another 10 will give me 360. Now, according to the cast rule, C-A-S-T, I know that in this quadrant, remember, we're dealing with the sine. I know in this quadrant, it's sine. And sine is negative in this quadrant. The only other place that sine is negative is actually in quadrant number 3. So the other picture, or the other angle that we're looking for is this exactly the same picture. This exact same picture with this exact same triangle, except in quadrant number 3. So I'll go and draw that. The other angle has to end up in quadrant 3. So I do this. I do that exact same drawing with that 10 degrees triangle in quadrant number 3. So looks something like this. Okay, this is theta. And drawing a line straight to the x-axis where this little bit is 10. So that's my other theta, because I know that sine is also negative in quadrant 3 because this is the t, only 10 is positive. And so how do I find theta? Theta shouldn't be that difficult to find here. Theta is just going to be, we know that this is half of a circle, 180, plus this little acute angle of 10. So theta is equal to 190 degrees. So sine of 350 is the same as sine of 190, and I would check that on my calculator to verify. The last question I want to go over is something like question 8. It gives us that cos theta is equal to negative 0.8722 and asks us to find all values of theta if it can rotate around all the way from 0 to 360, so one full rotation. This is where we have to be careful. We have to be careful because we have to remember the Castrol. We understand that our terminal arm starts here at angle 0, but it can go all the way around into 360 degrees. So it can go around and around and around into 360 degrees. Now, according to the Castrol, if we know the Castrol, we know that this is CAST, and let's take a look at what we're dealing with. What we're dealing with is cos is a negative number. Cos theta is a negative number. There are two places in the 4 quadrants, so there are two quadrants where cos is negative. Cos is negative in this quadrant right here, and cos is also negative in this quadrant here. So there are two spots that cos is negative. That quadrant and that quadrant there. So we are actually looking for two separate answers. One of the answers is in quadrant number 2, where the answer has to be between 90 and 180. And one of my answers in quadrant number 3. The answer has to be between 180 and 270. So let's go and take a look at this. Now, how do I solve this normally? How I solve this normally is quite simple. I just bring cos to the other side, so I do cos inverse of this negative 0.8722. And when I do this, and I actually do this on my calculator, if I round to the nearest degree, I get 151 degrees. So is that one of my answers? Yes, that actually is one of my answers. That is the answer that is in the second quadrant. So I'm actually going to redraw this over here. So you can see that this is my first answer. I get that cos of 151 is this negative 0.8722. So this is the first answer. I'm always going to end up with two answers, but this is the first answer. Now, if we draw the 151, it looks like this, and I draw a line straight down to the x-axis, we can actually figure out that this acute related angle is 29, because 151 plus 29 will give us the 180. So that's the answer in quadrant number 1. But how about the other answer that is supposed to be in quadrant number 3? Okay, so that's in quadrant number 2. That's the first answer there. How about quadrant number 3? Because cos is also negative in quadrant number 3. So if I draw that exact same replica of this exact same triangle, but in quadrant number 3, this is what it's going to look like. Here is my terminal arm, and I open up into quadrant number 3 like this. So I open up like that. That is my second answer right there. Now, drawing this triangle in quadrant number 3 to make it exactly like the last one, this is 29 degrees, the related acute angle. And so how do I find my second answer? My second answer, theta, is going to be, half of a circle is 180 plus this little bit of 29. And so I get that theta is going to be 209 degrees. So I actually get two answers for theta. How do we verify both answers are correct? I mean, we could just pop this in over there and do cos of 151, make sure that it's negative 0.8722. Well, it's something close because we rounded this. And also, if I also pop in that 209 in there, and I did cos of 209, it should also give me something very close to negative 0.8722. Let's do another one. So we have tan theta is equal to negative 0. Whatever. Now let's take a look at the quadrants and the Castrol, and we are going to figure out what we're dealing with here. We are dealing with the tan, and tan is negative. We're looking for two spots where tan is negative. The only two spots tan is negative in this quadrant here and also in that quadrant there. So our two drawings, one of the drawings is going to be in quadrant number 2 and the other drawing has to be in quadrant number 4. So how do I go about doing this? Well, I go about doing this just like I did last year. If I bring tan to the other side, and I do tan inverse of this negative 0.1623. If I figure this out to the nearest degree, the answer is negative 9 degrees. Clearly, this is not the right answer. This does not end up in quadrant number 2, nor does this end up in quadrant number 4. So how do we fix this answer to end up in one of those quadrants? Let's talk about quadrant number 2 first. So again, if we draw a terminal arm opening up into quadrant number 2, such as this, like this, what is that exactly telling us? If that's theta, what is this negative 9 degrees telling us? Well, if we remember from one of the other examples, if we draw a triangle straight down to the x-axis, what this is telling us is that this little bit here is your 9 degrees, the related acute angle. So we could figure out theta because we know all the way up into this axis is 180, but we just got to go backwards by 9 degrees. So we take 180 and we subtract 9 and we get that theta is equal to 171. So that's my first answer. My second answer has to end up in quadrant number 4. So I'm going to draw that exact same triangle, except I'm going to end up in quadrant 4. So here's my terminal arm. I open up all the way to quadrant number 4 like this. Okay, so I end up with a triangle. If I draw a line straight to the x-axis, there's my triangle where this is 9 degrees. And of course, I realize that this starts at 0 and ends at 360. Now, if I want to find this theta, opening up from here all the way up into this point here, where this little part inside here is 9 degrees, that should be no issue. Theta in this case is almost all the way around. It's almost 360, but I'm going to go backwards by 9 degrees and subtract 9 degrees and I end up with 351 degrees. Okay, these could be applied to all these in question number 8, but how do I know I've done this right? I mean, I could pop 171 right in there and I could do the tan of 171 and it better give me this number right here, negative 0.1623. Remember, that's a rounded answer, so it's not going to be exact. And of course, if I pop in the 351, the tan of 351, it should also be negative 0.1623 or something very close. Well, sadly, my time has come to an end. I'd like to take this opportunity to give a quick shout out to my peeps in the Explain Everything world. This app is simply amazing. Hopefully this video was helpful. I'm the math coach saying, thanks for watching and see you next time.